Okay, let's go ahead and finish these notes off. We're here at the last part of it. They're asking over here for us to go ahead and convert, and let me go ahead and zoom in just a little bit more, from moles and grams, okay? Find the mass of 0.045 moles of chromium, okay? So what am I looking for? Finding the mass. Mass is going to be in what? Grams. So I'm going to circle that part. Remember the last unit when we were doing dimensional analysis, I circled what I was looking for and I underlined what they gave me. Okay. Again, just like the last part, we're going to start off with what they gave us. And so they gave us, I'm going to scoot over here, 0.0450 moles of chromium. Chromium is Cr. It's on the periodic table, and like I told you already, you're definitely going to need one in front of you. It's right here, number 24. Okay, the mass number is 51.996. That means that we're going to round it to 52. Now, let's come over here and let's do this. If I have moles of chromium over here, and this is why we practice this with our other dimensional analysis, then just like algebra class, I need to have moles of chromium over here. So I'm going to go ahead and put that in, moles of chromium, so that way they can cancel out. And 1 mole of chromium, we said, what is the molar mass? 1 molar mass is equal to the mass here that's on the periodic table of 52 grams of chromium. Okay, now I can go ahead and I can cancel out the moles. I'm left over, look at this, I'm looking for mass. I'm left over of mass, G, grams. So I'm good. I can stop where I'm at. I can go ahead and solve this problem. I'm going to multiply the top number. The bottom number is 1 because it's just 1 down there. So 2.34 over 1, or 2.34 grams of chromium. Now let me go ahead and stop for a moment, and I'm going to write this down. If you have not printed out the formula chart, you're definitely going to need to print one out. On that formula chart, it has some really good information, and it has a little chart here for you to use, so that way you can do your conversions between moles to mass and to compounds. Okay, whether it's going to be molecule compounds or whether it's going to be the formula unit compounds, all right? Now I'm trying to look for my chart as well, right? I'm telling you, you need to have one, but now look, I'm trying to find my chart as well. So, where's my chart at? It's not there. And this is not the chart over here. That's okay. Let me write out over here on the side of my notes what the chart says. You might want to write it here in your notes too. It is on your chart, but if you don't have your formula chart in front of you, go ahead and write this down like I am. In your formula chart, there is a little box, and in that box it has this information. Grams to moles, and from moles to particles. And particles can either be atoms, molecules. Remember, a molecule is a nonmetal with a nonmetal bonded together, or what we call a formula unit, and the abbreviation for formula unit is FUN, F-U-N, or what we call ions. Okay, now we're going to get to these in a little bit, and we'll get to ions later on. Let's go ahead and look at this little chart. This is what it looks like on your formula chart. What I'm trying to say here with this little section is that If I have grams, I can go to moles. And if I have moles, I can go to particles. But if I have grams, I can't just jump and skip to particles. This is like a stair step, like a ladder, and I have to go from step to step to step. I cannot jump steps. If I have atoms, I can't just jump to grams. I have to go from atoms to moles, from moles to grams. If I have grams and I want formula units, I have to go from grams to moles, from moles to formula unit. You have to go in this way. And this is the stuff that you're going to use when it comes to your dimensional analysis. Kind of like last unit, we had those little charts and we were going from feet to inches, and from inches to yards, and yards to miles. This is how we're going to do this. So in chemistry, we go from grams to moles, and from moles to particles. If you have moles, you can go straight to grams, or you can go straight to particles. Okay? So the other thing that we need to know, as a quick little hint, is when we're looking at this little chart here, kind of like a flow chart, if you're going from grams to moles, or from moles to grams, you must have the molar mass. And let me go ahead and tell you, they're not going to give you the molar mass. You're going to have to go to the periodic table. So the molar mass is from the periodic table. And you're going to have to find that molar mass. So if you have grams and you're going to moles, you're going to need the molar mass. If you got moles and you're going to grams, you're going to need the molar mass. Let's look over here. We had moles, right? And we were going to grams. And what did we have to do right here? We had to get the molar mass from the periodic table. Let's go back and look at our chart. If we're going from moles to particles, or from particles to moles, we need Avogadro's number. Which is 6.02 times 10 to the negative 23rd power. Oh, sorry, to the 23rd. I don't know why I wanted to say negative. It's a positive value. Okay, so if you have particles and you have to come this way, you're going to have to utilize Avogadro's number to get to the moles, and then from moles over here. And let's continue to practice. It is definitely going to take practice, so that way we can get better at this. Let's go back and let's look at the next one. If you weigh out 90.5 grams of aluminum, how many moles do you have? Okay, so again, what am I starting off with? If you weigh this out, how many moles do you have? Question mark. That's what I'm looking for. What do I do on dimensional analysis? I always start off with what I have. What do I have? I have 90.5 grams of aluminum. Okay. I'm going to go ahead and look over here. I have grams. What am I trying to get to? I'm trying to get to moles. What am I going to need? I'm going to need the molar mass. Okay. In class, when we get to this part of the notes in class, I will finish it and go over this this question right here, just to make sure. But hopefully you practice it yourself and at least try it before we have class. Let's go to the next one right here, and I will help you. It says we're going to be converting how many AU is gold, okay, atoms are in a 25 gram of pure gold nugget. So here's what I have, and I want to know how many atoms. That's my unknown. What do I do in dimensional analysis? I write down what they gave me. They gave me 25 grams of gold, AU. Okay, look at your flow chart or look at your notes over here. Grams of AU is what I have. What am I going to? I'm going to atoms. So I'm going to jump from here to moles and from moles to particles. I've got to do those jumps. I can't just skip one. So if I have grams of AU up here, then I've got to have grams of AU down here, right? Just like algebra class, I want to cancel out. Where do I get this information from? Come back to this section. I go from grams to moles, and I have to go to the periodic table. So let me come over here and find AU, which is right here, gold, number 79. It has a molar mass of 196.967. What does that mean? I'm going to round up to 197. Okay, So 197. I will tell you that some teachers like to go ahead and keep that number at 196.97. That's just kind of I guess a preference. Okay. I'm going to personally keep it myself, 196.97. Okay. When you do your answer, I mean, you might be like a hundredths off, 1/100ths or 1/1000ths off. Okay, we're not to the point right now that we have to be so exact because we're in the chemistry lab and we can't be off, not even by a hundredths. Okay, but I'm going to go ahead and just leave that there. Again, though, we do prefer to just round it. Okay, it makes it a lot easier for us. But this is equal to 1 mole of AU. Let's cancel out the grams of AU. Am I where I need to go to? I need to get to atoms. I'm at moles. I'm not there yet. But I have to put moles of AU down here so they can cancel out. And I know that 1 mole of anything, 1 mole of anything, 1 mole of a compound, 1 mole of atoms, 1 mole of ions is equivalent to Avogadro's number. And so if we're ever going to be in this section of this little flow chart, you must use Avogadro's number, which is 6.02 times 10 to the 23rd atoms of AU. Now my moles of AU get to cancel out. I'm left with atoms of AU, which matches up with what I was looking for. I'm done, and I can go ahead and do my math. Multiply the top row, multiply the bottom row, and then let's divide. So let me start off here because I think some of us may need this. I'm going to go grab my my graphing calculator. Make sure you have your calculator with you. And the reason why I want to grab my calculator is because I want to make sure that we're all on the same page. Some of us may or may not be familiar with how to use a graphing calculator, and you may not have really had to use it very often. You probably did, but it probably wasn't very often. So let's go ahead. I'm going to turn it on, clear it out. So let's look at this. I'm going to type this in. I personally like to type everything in the top, then go ahead and get my number, type everything at the bottom if I need to multiply more than 1, get my number, and then go ahead and divide. I know some students like to type everything in one shot. Not a problem. If you're one of those people, go for it. But please make sure you use parentheses around those numbers, because if not, the calculator's not going to know that. So let's look at this. 25, and I'm going to go ahead and use parentheses. Close parentheses, multiply, well, I'm not going to multiply by 1 because multiply anything by 1 is itself. But what is important is the open parentheses, 6.02 times 10 to the 23rd. You do not literally hit the multiplication number here. That's not how you do exponents. For exponents, for me, I know there's more than one way, but the step that I use is the second key and then the comma. You see that little EE? This is the one right above the number 7. I hit that one, and it has the little E above it, or the E right here. I'm going to type in 23. That E stands for exponent, or times 10 to the, close parentheses, enter. All right, so 1.505 times 10 to the 25th power. Okay, so 1.505 times 10 to the 25th power. The bottom number is 196.97. I need to divide those numbers, so I'm going to get this number, and I'm going to divide by parentheses 196.97, close parentheses. I get an answer of 7.64 times 10 to the 22nd. So my answer, I'm just going to put a little arrow over here, is 7.64 times 10 to the 22nd, hold up, atoms of AU. We must put our SI unit behind it. Alrighty, so there goes our answer. We've got some more to practice, but I'm truly feel like you need to try some of this on your own. Even if you at least underline what you have, circle what you're looking for, and if anything, why don't you at least write down what you have? And for an example here, if I have grams of AL, then down here I know I've got to put grams of AL. So why don't you do that step also, and do that for here, here, and here. And if you can try it on your own, that's awesome, because you know you're going to have to eventually do it on your own. Okay? If not, we will do this section in class because I want to make sure you have all the right answers. Okay? But other than that, we are done with our notes as of now. And our notes, remember the calendar date changed, so we still have quite some time before our notes are due. Alrighty, you have a great day. Bye-bye.